So here is the question I get more than almost any other. How many proxies do I actually need for this scrape? And people want a round number back, 50, 1,000, a clean figure they can drop into a budget. But the honest answer is that it is arithmetic, and the number falls out of two things: how fast you want to pull and how fast the site will quietly tolerate each address. Get that math wrong in one direction, and every address you rent gets burned in an afternoon. Get it wrong in the other, and you are paying for a huge pull you never needed, and sometimes making yourself easier to spot. I run proxy farms and production scrapers for a living, and sizing a pool is something I do for real jobs with real budgets, not a chart I copied off a vendor page. So today I want to walk through the actual math I use, the simple formula that turns your target rate into an address count, why more addresses is not always better, and how the size of your pool ties into rotation. No magic number, no talk of undetectable pools, because that is not a real thing, just the arithmetic. Sizing is a rate problem. Start by throwing out the idea that this is a count problem. You are not really asking how many addresses you need. You are asking how much traffic you want to push and how thinly you have to spread it so no single address gets noticed. That reframes the whole thing. The pool exists to divide your total load across enough addresses that each one stays under the rate the site will accept from a single visitor. Once you see it as spreading a rate, the number almost calculates itself. The two numbers you need, so you need two numbers before you can size anything. The first is your target request rate, how many requests per second you want the whole job to make. That comes from how much data you need and how quickly you need it, and you set it. The second is the safe rate per IP, how many requests a single address can make against this particular site before that site starts treating it as suspect. The first number you choose, the second number the site decides for you, and you have to go and measure it. Finding the safe rate per IP, that safe rate is the number people skip, and it is the one that matters most. You do not guess it, and you do not read it off a vendor page, because it is a property of the target, not of your proxies. You find it by running a small test against the real site, one address, slowly raising the rate, watching for the point where the block rate starts to climb or the challenges start to appear. Then you set your safe rate comfortably under that ceiling. The site never tells you the number out loud, but its behavior does. The formula in words. Now the formula, and it is simple enough to hold in your head. Your IP count is roughly your target request rate divided by the safe rate per IP. That is the whole thing. If you want the job to make a certain number of requests per second, and each address can safely make some smaller number per second, then the first divided by the second tells you how many addresses it takes to carry that load without any one of them going too fast. Everything after this is just adjusting that result. A worked example, let me make it concrete. Say you want the whole scrape to run at 20 requests per second. And say you have measured that this site tolerates about one request every 5 seconds from a single address before it gets unhappy, which is a safe rate of roughly 0.2 requests per second per IP. Divide 20 by 0.2 and you get 100. So you need on the order of 100 addresses to push 20 requests per second while keeping each one at a pace the site accepts. That is your starting number, not your final one. Add headroom, because 100 is the floor, not the answer. Reality is messier than the math. Some addresses in any pool are already burned before you touch them. Some go stale partway through the job. Some fail for reasons that have nothing to do with you. So you add headroom, take that clean number and pad it, usually by 30 to 50%, so the job still hits its rate when a chunk of the pool is unusable at any moment. So 100 becomes closer to 150 in practice. Round up, never down. Concurrency is a different dial. Here is where people tangle two things that are not the same. Concurrency is how many requests are in flight at the same instant. Rate is how many you complete per second over time. You can run high concurrency at a low rate if each request is slow, or low concurrency at a high rate if each is fast. The sizing formula is about rate, not concurrency. Do not size your pool of how many parallel connections you happen to open. Size it of the sustained rate you actually push through them. Politeness sets the denominator. Notice that the whole formula hangs off the safe rate per IP. And that number is really a politeness choice. The lower you set the per address rate, the gentler you are on each one, and the more addresses the math asks for. Push each address harder, and you need fewer of them, but you burn them faster. So sizing and politeness are the same decision wearing two hats. I tend to set the per address rate well under the measured ceiling, which costs more addresses upfront but keeps the pool alive far longer. Why more ipsies is not always better. Now the part that surprises people, a bigger pool is not automatically safer, and past the number the math actually calls for, more addresses can hurt you. Every address you add is one more with a reputation you did not build and cannot see. A huge pool spread thin is a crowd of strangers, and if a slice of it is already dirty, you inherited blocks you never earned. You are also paying for capacity you are not using, which on metered residential pools is real money leaking for nothing. A swarm has its own signature. There is a subtler cost too. Edge defenders do not just watch single addresses, they watch across a whole site and across many sites at once. A sudden swarm of fresh addresses, all crawling the same paths at the same speed, is itself a pattern, even when no single address is going too fast. So throwing 1,000 brand new addresses at a job that only needed 100 can raise your footprint instead of lowering it. The right size is the smallest pool that carries your rate politely, not the biggest one you can afford. Pool size and rotation are linked. This is where pool size and rotation meet, and they are not separate topics. Rotation just cycles you through the pool, handing out a fresh address on a schedule or per request. But rotation can only spread your load if the pool is big enough. If the pool is too small, the rotator comes back around to the same address too soon, and that address ends up carrying more than its safe rate anyway. So a pool below the size the formula asks for does not actually lower your per address rate, no matter how aggressively you rotate. The rest window, think of it as each address needing a rest between uses. If the safe rate is one hit every 5 seconds, then after an address is used, it should sit idle for about that long before it comes up again. The pool has to be large enough to fill that gap for every address in the rotation. In effect, the pool size is your rate multiplied by how long each address needs to rest. Rotation and sizing are two views of the same constraint, keeping every address under its safe rate over time. Sticky sessions change the math. Stateful work flips the calculation. If you are walking a login, a cart, a multi-step flow that has to stay on one visitor, you cannot rotate mid-session without contradicting yourself. So there you size by concurrent sessions instead of by raw rate. You need roughly one address per session you want running at once, plus a batch of spares for the ones that fail. It is a different formula for a different shape of job, and mixing the two up is how people end up wildly over or under provisioned. Proxy type shifts the denominator. The type of proxy does not change the formula, it changes the safe rate that goes into it. On a strict site, a data center address might tolerate almost nothing before it is flagged, so the safe rate is tiny and the math demands a lot of them. A residential address reads as an ordinary person and tolerates more, so you need fewer. The tier you pick moves the denominator up or down, which moves the count, but the arithmetic underneath is exactly the same either way. Mobile is the odd one, because a single mobile address is already shared behind carrier-grade net by many real subscribers. That shared crowd is doing some of your hiding for you, so you rarely size a mobile setup by raw address count. Instead, you size it by how many concurrent sessions you run through the gateway and how often you rotate. This is the tier I built myself, and for the hardest targets, a handful of real mobile addresses can outlast 1,000 cheap data center ones, so the count you need is far smaller. Measure, do not trust the headline, one warning that ties it together. The pool size a vendor prints on the box, millions of addresses, tells you nothing about how many you need or how many will actually work on your target. Your number comes from your own measured safe rate against your own site run through the formula plus headroom. I have watched a tiny well-maintained pool beat a giant dirty one on the same job, so measure first, size from the measurement, and treat the marketing number as noise. I run this stack in production every day, sizing real pools against real targets, so this is the math I actually live with and not theory. If you want to go deeper, The full written guides and the proxy pools I genuinely test and use are at dataresearchtools.com, where I show the block rates and the sizing I land on with no undetectable promises. The mobile tier I build is the one I reach for when a target has beaten the cheaper pools because a small shared pool goes a long way. If the honest limits, let me be straight about the edges. Sizing a pool correctly keeps you polite and keeps the job alive, but it does not make anything undetectable, and no address count changes what you are allowed to collect. Public data only, the robots file respected, and official API or bulk feed preferred wherever one exists. The formula is about carrying your load without leaning on any single address too hard. It is not a way around the rules, it is just how you stay a quiet, well-behaved stream of traffic. So to recap, sizing a pool is a rate problem, not a count problem. Take your target request rate, divide it by the safe rate per IP you measured on the real site, and that is roughly how many addresses you need. Then add 30 to 50% for headroom. Do not confuse concurrency with rate. Remember, the pool has to be big enough for rotation to actually rest each address, and size sticky flows by session instead. More addresses is not automatically safer, so pick the smallest pool that carries your rate politely. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.